Hello, welcome to the video. And in this project, I have used Resident 50 to classify 102 flowers dataset into 102 different classes, which corresponds to 102 different species of flower. Now let's dive into the notebook and see how everything is set up. First of all, let's talk about the data. The data here is a collection of images, and the labels information of the data is given by the image labels at Mat5. And similarly, the split information on which images belong to the train, test, and validation set is given by the set id.map file. We'll be extracting this file and get the information that we will require. So first of all, we'll get the indices of the train, test, and validation images and the labels of those images as well. We'll extract these files and we'll print out the keys to see where the information that we actually need is stored. Okay, and after extracting the labels, we'll get the labels of the images. We'll just pattern these arrays because we have one extra dimension. And similarly, we'll use these keys train ID, valid ID, and test ID, TST ID to get the indices of the images that belong to these sets. We'll print the shape just to get the idea of the train, test, and validation test set sizes. And finally, we'll print the first five values of these arrays. 8,189 images are there in our dataset, and our width 1020 belong to the train set. Similarly, for the validation set as well, there are 1020 images, and finally 6,149 images in the test dataset. Okay, now first five values of the label array gives us the labels of the first five elements. So first five images, that is the label of the first image is 77, and similarly the label of the second image is also 77, and so on. And the values of the train indices will give us the indices of the images that belong to the train set, train set, and the validation and the indices of the validation valid ideas array will give us the indices of the images that belong to the validation set, and the same for the test indices. These are the indices of the images that belong to the test set. Now we print out the mean value of these indices to see what our index actually start from. Here our index start from 1 and our image number is also start from 1. You can see here image 01, image 02. Now our labels, there are 102 labels and the label values are 1 to 102. For simplicity, we'll be converting it to 0 to 101 later in our custom data set. Now it's taking a lot of time right now. And now we'll get the path of all the images in the data raw folder, and we'll use this list of paths to retrieve the images for train, test, and validation set. For every images in the train IDX, we'll get the indices, and we'll put that indices in this list of path to get the path of the images that belong to the train set. And similarly for the test images as well, we'll retrieve the indices and pass those indices in the list of the paths. Okay, we'll print up the length of the train, test, and validation images just to see that we have got everything right. Now we'll prepare a custom dataset in PyTorch, and we will be using the auto transform of the Resident 50 model to get the standard deviation and mean. And similarly, we'll define our transformation as well, but we won't be using all the transformation that is used on the actual Resident 50 model. Now finally, we'll make an instance of the custom dataset and apply the transformation that we have defined. We'll get the model, words of the model, and then we'll get that auto transform, and we'll use the mean and the standard deviation from the words, that is auto transform mean and auto transform standard deviation. And we'll apply the random relative flip as the data augmentation. We'll convert the image to tensor, and we'll be copying the pixel size to 224 by 224. And for the validation transform, we won't be applying any sort of data augmentation. Now we'll load our custom data set, that is image data set, and we'll pass the train images, that is the list of the paths of the images that belong to the train set, and similarly for the val and test data as well. Let's see how our custom dataset image dataset is defined now. Okay, here we're going to make a custom dataset that will take images, labels, and transform as arguments. We'll override the get item that we need to do whenever we are defining a custom dataset, and we apply the transformation and return the data and labels as default. First of all, we'll assign the attributes, and we'll be overriding the get item method. we'll get the index from the user. We'll pass that to the list of the paths to get the path of the image that we actually need, and we'll open it using the pil.image function, and we'll get the label as well. Similarly, like how we get the image, and we'll apply the transformation, and finally return the image and the label as depot. We'll be decreasing the value of label because we want our labels to be from 0 to 101, and we'll be overriding the len function, len method as well. Now let's go move back to the main notebook. Here we have got our train, val, and test data, custom data set. And now we will just print out our original data set and transform original image and the transform image. This is how our original image looks, and this is how our transform image looks. Now let's convert our data set into data loaders. We'll be defining our batch size, and our data loader will be giving us the data into iterators. We'll pass the train data, batch size, number requests, and we'll be suffering our data set. For the test and val data loader, we won't be suffering our data. Now let's define our train and test loop. We'll replace the last fully connected layer of the destination 50 with our number of classes, that is 102, and then freeze all the layers except that fully connected layer. We'll define the loss function and the optimizer, and finally run the training loop. First of all, let's load the model and replace the last fully connected layer. Then we'll freeze all the layers except the final fully connected layer here. And now define the loss function and optimizer, but before that we'll send our model to the device, and then we'll be defining cross entropy loss and using RM optimizer. Now we'll be running our training loop. Okay, for running our training loop, we need to see our three functions, that is accuracy function, train step, and value step, that we have defined in the train.py. Here, let's see our accuracy function will just take the prediction values and true labels, and for every prediction that is equal to the true labels, we'll be adding those. We'll be getting all the true label. Actual. For every prediction that is equal to the true value, we'll get the true value, and we'll sum it, and we'll divide it by the path length of our true labels. Finally, and then for our train step and value step, we'll take the model, data loader, loss function, optimization, and accuracy as a parameter, and we'll put the model in the train mode, set up the train loss and train accuracy values to zeros, because we'll be getting the train loss and train accuracy for each batch, and then finally we will be accumulating it and returning the average of the train loss and train accuracy values that we have got. We'll get the images and labels from every batch. We'll send the data to device, compute the logics, and then pass the logics to get the loss function, and then send the loss backwire. Then we'll get the actual prediction probabilities from the logics and pass the probabilities to our accuracy function. Finally, we will compute the loss and accuracy, and we will be accumulating the loss and accuracy. And here we have taken the average of them, and we are returning the train loss and train accuracy. And the process is similar for the value step as well, except that the model will be in the evaluation mode, and we'll be turning on the inference context manager because we are making a prediction here. And we'll get the data from the batch, and then get the logics by forward pass, and we'll compute the loss and calculate the actual prediction probabilities, accumulate the accuracy. Then finally we'll be returning the average of the loss and accuracy. And this function eval mode is used to make the inference on the test data. Here we'll be taking the model, data loader, loss function, accuracy, and device, and we'll be returning a dictionary with model name, loss, and accuracy. First of all, we'll set our loss and accuracy to 0, and our model will be in evaluation mode. We'll turn on the inference mode context manager. We'll get the data and label from the data from the data loader for each batch, and we'll send the data to device, compute the logics, find the prediction probabilities, and then finally compute the loss and accuracy. We'll be accumulating them, and then return the average of the loss and accuracy. go back to the main notebook again. Now we'll be saving our model. We'll be defining the path where our models needs to be saved. Our model name is going to be ResNet version 0. And then we'll be saving the model. We'll load the model, but first we need to create an instance of the ResNet 50 model. We are going to set the pretend to false because we have already trained our model. And we'll be adjusting to 102 classes, that is by replacing the final fully connected layer. Now we will load the model, and then finally we'll make the prediction on the test dataset, and we'll get the loss and accuracy here. Hi everyone, I'm Dipen, a computer engineering student from Nepal, and currently I'm in the 8th semester. My passion for coding and mathematics began back in school, but it was during a workshop at Robotics Club that I was introduced to the world of AI. The perfect blend of mathematics and coding in AI really fascinated me, and I was hooked from that moment. Winning my first hackathon at my freshman year really opened my eyes to how technology can be used to solve real world challenges. I saw my seniors use AI to projects like number plate detection, lung cancer diagnosis, and I was just really amazed by how AI has been used to solve these real world challenges and make impact in the life of people. This program of Philosophic.ai is, I think, the best platform for me to grow professionally and learn the skills from the experts, and as well as get the perfect networking opportunities to work with the like-minded people. And I really wish to savor every moment that I will be having in this program. Thank you.